Hello guys, welcome back to the next class. Here we'll discuss the assignment which I gave in the previous class. So first of all guys, quickly can match your answers. Eighth problem answer is x belongs to open square root 5 minus 1 by 2 to closed one. Ninth is minus infinity open to minus 1 open. 10th is close minus 1 to close 2 union close 4 to close 7. 11th open minus infinity to minus 2 open union minus 1 to 1 both open union 2 to 3 both open union 4 to infinity both open. 12th x belongs to open minus 2 to open minus 1 union open minus 2 by 3 to open minus 1 by 2. 13th x belongs to minus infinity to minus 2 both open union minus 1 to 1 by 2 both closed union open 3 to open infinity union only 2 excluding 0. 14th x belongs to minus 2 to minus 1 both open union 2 to 3 both open. 15th x belongs to minus 1 to 2 both closed. So there were 8 problems. So out of 8 problems, how many got correct? You can type in the comment section. Now we'll start discussion of each of them. So whichever problem you have got wrong or you could not solve, you can just jump to its discussion. We'll discuss each and every problem one by one. First of all, eighth one. Now this was one of the typical problem. So if you have got this one right, that means you are very good in the concept then. And those who got wrong, guys, you can see this thing. So first of all, this thing x greater than square root of 1 minus x. This we have to solve. And whatever things we discussed, the thing inside square root should be greater than equal to 0. So 1 minus x should be greater than equal to 0. From here we get 1 will be greater than equal to x, or we can say x is less than equal to 1. Now, second thing, I told you the square root value will always be positive only. So square root of 1 minus x will be greater than equal to 0. If you want x to be more than this, can I say x also will have to be greater than equal to 0 only? Because if x is negative, then it won't be greater than a positive number, no? So from here we can conclude that x will be greater than 0 also. X equal to 0 will not satisfy, so I have directly taken x greater than 0. Finally, we are looking for those numbers which will satisfy the equation. So x equal to 0, you can see, does not satisfy. So we get x greater than 0 and x less than equal to 1. So common values are for now open 0 to close 1. So our final answer should lie inside this only, because only for this the equation is defined. Now how do we solve? We have x greater than root of 1 minus x. Now we have made sure that both are positive, no? Because x is greater than 0, this thing always positive. So if both are positive, we can square and inequality will be same. So we get x square more than 1 minus x. We bring everything to one side, you get x square plus x minus 1 greater than 0. Now for this equation, d might look like negative, but d is positive here, and the roots will be irrational. They look something like minus 1 plus minus square root 5 by 2. Minus 1 plus minus square root 5 by 2. So this thing will be rationalized as x minus minus 1 minus root 5 by 2, x minus root 5 minus 1 by 2 greater than 0. So you plot the roots on the number line. Now approximate value of the roots you have to see. Square root 5 is approximately 2.7. No, not 2.7, around 2.2. So if I assume it to be like 2.2 and minus 1, So it will be minus 3.2 divided by 2, it will be around 1 minus 1.6. So just less than 0. That is what matter here. So we can say this root is negative. So we'll plot it before 0, and square root 5 minus 1 by 2, I think it's approximately 0.6. Taking root 5 to be 2.2. So 2.2 minus 1 will be 1.2 divided by 2 will be 0.6. So this root will lie between 0 and 1. And using the wavy curve will be positive, negative, positive. You want greater than 0. So you see greater than 0 will be before this negative root and after this root. But initially we have made sure that we have found out that x has to lie between 0 and 1. So we'll keep our number line between 0 and 1 only. So we look between 0 and 1 only. That's the pink part. In this pink part, you can see after this root, it is positive and before it is negative. So we can take x to be only greater than this, but up to 1. So it will be square root 5 minus 1 by 2 to 1. What bracket to be used here? See, you want strictly greater than 0. So root 5 minus 1 by 2 is a root. So if I put that, it will become 0. So it has to be open. But what about 1? 1 will be closed here. 1 doesn't feature here. So if you want to select 1 if it is open or closed, you can just put 1 in the original equation. If you put 1 here, you will get 1 greater than 0, which is true. So 1 satisfies the original equation. So we can say it will be closed. So final answer is square root 5 minus 1 by 2 to 1. Where square root 5 minus 1 by 2 is open and 1 is closed. Next, ninth problem. In the ninth problem, we have x cube plus x square plus x plus 1 less than 0. What do we do here? We factorize. We take x square common from here. We get x square into x plus 1. And this just x plus 1. Now from these two, x plus 1 is common. You get x plus 1 into x square plus 1 less than 0. You will see that x square plus 1 will not have any real root. It will always be positive. You can see directly also x square plus 1 will always be greater than equal to 1. So we can just ignore this part, or you can say d negative, c positive, always positive. That thing also you can use here. So x plus 1 only, just so 1 is minus 1 is the only root, positive, negative, you want negative, so x will be less than minus 1, so minus infinity to minus 1, both open. I hope this is clear, guys. This was not very difficult. And next, 10th problem. The 10th problem we have, now it's a very good question, but we can solve it easily. So we have x square minus 6x plus 3, x square minus 6x minus 2 less than equal to 50. There is no direct way here right now because the right side used to be 0, but now it is 50. We can use the wavy curve only when the right side is 0. So we cannot use the wavy curve right now. So what we have to do is we have to make the right side 0. And how can we do it effectively? By seeing this x square minus 6x as t. You see x square minus 6x, here also x square minus 6x. So just for time being, I will take it as t. It will help us simplify easily. So this become t plus 3. It will be t minus 2 less than equal to 50. So you get t square plus t minus, like when you simplify, t square plus t minus 56. Like this 50 we bring this side. You finally end up with t square plus t minus 56 less than equal to 0. Now you factorize that, you get t plus 8, t minus 7 less than equal to 0. And now you can put t as x square minus 6x. You put back here t as x square minus 6x, you get x square minus 6x plus 8 into x square minus 6x minus 7 less than equal to 0. Now you can factorize these. So this quantity will have roots 2 and 4. This will have 7 and minus 1. You plot them on number line, then use the wavy curve method. Finally end up with the answer as close minus 1 to close 2 union close 4 to close 7. So it's a very good problem, but you can do it easily with the help of this method. Next problem. Next problem is this. We have a quadratic, a cubic, a quadratic, a cubic. For this cubic, we can just use a cube plus b cube, which is a plus b into a square minus ab plus b square. So, and just find the roots of each quadratic. This will be 1 and 2. This using the identity will become x plus 1 into x square minus x plus 1. This roots will be 3 and 4. This again a cube plus b cube, we get x plus 2 into x square minus 2x plus 4 greater than 0. I will see this quadratic will always be positive. D negative, C positive. This quadratic is always positive. D negative, C positive. So just ignore these two. Remaining all the roots you can plot. -2, -1, 1, 2, 3, 4. Wavy curve. You want greater than 0, so it will be minus infinity to -2, union -1 to 1, union 2 to 3, union 4 to infinity. All open. I hope it is clear, guys. Next problem. In the next problem, we see we have like fractions here. So rational functions, we can see them, but let us just not go into that. You can simply say we have 2x by 2x squared plus 5x plus 2 greater than 1 by x plus 1. And like we discussed, do not cross multiply. Bring everything to one side and take LCM and solve. So when you bring this to this side and take LCM, you finally end up with this minus 3x minus 2 by, and this quadratic we can find the roots will come out to be, I think, minus 1 by 2 and minus 2. So the factors will be 2x plus 1, x plus 2, x plus 1, and this minus 3x minus 2, this negative is on this side, you get less than 0. So now plot the roots. So minus 2, minus 1, minus 2 by 3, minus 1 by 2, positive, negative, positive, negative, positive. You want negative. So negative is between minus 2 and minus 1, minus 2 by 3 and minus 1 by 2. I hope it is clear. Next problem. This 13th one. Now directly you have to solve, nothing you have to do before that. We just see which roots are odd times, which are even times. So odd times are minus 2, minus 1, 1 by 2, 3. Even times are minus 8, 0 and 2. And the roots of denominator I have boxed because denominator should never be 0. So these has to be handled carefully. What are the roots of denominator? Minus 2, 3 and 0. 0 for this. Now you plot only the odd roots here. So minus 2, minus 1, 1 by 2, 3, positive, negative, positive, negative, positive. But mark the even roots also to remind ourselves that the value at that is 0. There will be 2, 0 and minus 8. I want greater than equal to 0. So positive we have before minus 2, between minus 1 and half, after 3. Now whichever root is the numerator, we'll keep it closed. Denominator will be open. So minus 2 here will be open. Boxed, no? Minus 1 and 1 by 2 both are closed. 3 will be open because boxed here. After that, now you want greater than equal to 0. So the roots of numerator, we have to make sure we have taken all of them. So basically this 2, 0, minus 8 we have to see. So see minus 8 is a root of numerator. So we have to include that. But you can see minus 8 will already be there when we take minus infinity to minus 2. So no need to add it again. Next, 0. 0 is a root of denominator, so it should not be taken, but you will see it will come between minus 1 and half. So we have to exclude 0. Next, 2. 2 is the root of numerator, so it must be taken, but it will not come here right now because it was between 1 by 2 and 3. That interval we have not taken, so 2 we have to add separately. So this is your final answer. I hope it is clear. Next problem. 14th is exactly same as I think 10th problem. Just we take x square minus x as t, and then you guys can like try it yourself again. It's just exact same procedure as the 10th one. Otherwise, you can see this thing now. T square minus 8t plus 7 less than minus 5. We get t square minus 8t plus 12 less than 0. Roots will be 2 and 6. Then put t as x square minus x. Again, you factorize. Plot the roots on number line. Use the Wavey curve. We get the final answer. I hope this will be clear to all of you. Now last, the 15th problem. We have square root of 2 plus x minus x square. You want it to be more than x minus 4. So again, first the thing inside square root has to be greater than equal to 0. So 2 plus x minus x square greater than equal to 0. You can again factorize and use Wavey curve. You end up with minus 1 to 2, both closed. And we know this left side will always be greater than equal to 0. Right side is x minus 4. You see, when x belongs to minus 1 to 2, basically when we have defined here x, now x will stay in this range only. That whatever solution we are looking for should be between this only, because the left side will not exist for any other value. So if x we stick to minus 1 to 2, the right side value will be, if I put x as minus 1, we get minus 5. If I put x as 2, we get minus 2. So when I say x minus 4 in this interval is always negative. Okay, this thing is not required, I think. Let's show it that. So, what do we see here? So, in the given interval that we have, minus 1 to 2, not the given interval, the interval we found out for which it is defined, the left side is always positive, right side is always negative. So, obviously, this will be greater than this. So we need not solve anything after that. Directly we can say answer will be close minus 1 to close to. Because other than that, we cannot take any value of x. The equation will not be defined only. And for all these values of x, it is always true. So answer will be close minus 1 to close to. That is all. I hope the concepts are clear here. So this is the end of Wavy curve chapter. So whatever we have learned here will be used in literally every chapter. Uh, and next after this, we'll start modulus function. Modulus function is also a very important topic. Will be used everywhere. Okay, guys. Bye bye.